podcast, Wrapping and Unwrapping Data, Encapsulation. Hello, and welcome to the show. Today we talk about networking again. Our topic is encapsulation. That is a big word. Do not worry. I will speak slowly. I will use easy words, and I will say the big word many times. Soon it will feel easy. Are you ready? Let's start. What is encapsulation? Encapsulation is a big word for a small idea. It means wrapping. Data goes down the layers. Each layer wraps the data. Each layer adds a little bit of information. That little bit is called a header. There is a second word too. It is de-encapsulation. This means unwrapping. It happens on the other computer. Data goes up the layers. Each layer takes off one header. So remember two easy words. Wrapping is encapsulation. Unwrapping is de-encapsulation. One computer wraps. The other computer unwraps the letter and the envelopes. Let's use a simple picture. Think about a letter. You write a letter. This is your data. Now you put the letter in an envelope. On the envelope, you write an address. Then you put that envelope inside a bigger envelope. You write a new address on it. You do this again and again. Envelope inside envelope inside envelope. This is encapsulation. The letter is the same, but now it has many covers. Each cover has its own address. Each cover has its own job. Header and payload. Now two more easy words. Header and payload. The header is the front part. It holds control information. For example, an address or a number or an error check. It is small. The payload is the real data inside. It is the thing we want to send. Here is the key idea. A layer gets data from the layer above. To this layer, that data is just the payload. The layer does not open it. The layer does not read it. The layer only adds its own header. Then it sends the data down. This is very important. A layer does not need to understand the payload. It only cares about its own header. This is why the layers are separate. This is why the layers are simple. Wrapping on the sender. The names change. Now let's go down the layers on the sender's computer. Watch the data get a new name at each step. We start at the top. The application layer has the data. Here we call it data. This is your message. Next is the transport layer. It adds a TCP header. The header has port numbers. Now the data has a new name. We call it a segment. Next is the network layer. It adds an IP header. The header has IP addresses. Now it has a new name again. We call it a packet. Next is the data link layer. It adds a header and also a small tail. We call the tail a trailer. The trailer checks for errors. Now the data has a new name. We call it a frame. Last is the physical layer. It does not add a header. It changes the frame into bits. Bits are zeros and ones. They travel as a signal. So the name of the data changes at each layer. Data, then segment, then packet, then frame, then bits. 5 names. Same data inside. More covers on the outside. A memory trick. This order is a very common question. So let's make it easy to remember. The names are data, segment, packet, frame, bits. Look at the first letters, DSPFB. Now say this funny sentence. Do sergeants pay for beer? Do is data. Sergeants is segment. Pay is packet. For is frame. Beer is bits. Say it one more time. Do sergeants pay for beer? Data, segment, packet, frame, bits. Nice and easy. Unwrapping on the receiver. Now the data arrives at the other computer. Here we do the opposite. We unwrap. This is de-encapsulation. The data goes up the layers. First, the physical layer gets the bits. It puts them together into a frame. Next, the data link layer checks the error trailer. It reads the MAC address. Then it takes off its header and trailer. Now we have a packet again. Next, the network layer reads the IP address. Then it takes off the IP header. Now we have a segment again. Next, the transport layer reads the port. It puts the segments in the right order. Then it takes off its header. Now we have the data again. Last, the application layer gets the data. It gives the data to the right app. For example, your web browser. Do you see the pattern? Each layer reads its own header. Then each layer removes its own header. Then it passes the rest up. The header from one layer on the sender is read by the same layer on the receiver. They are partners. They talk to each other. A real example. The size grows. Let's see a real example with numbers. This shows why headers have a cost. Say an app sends 100 bytes of data, just 100 bytes. The transport layer adds a TCP header. It is 20 bytes. So now we have 120 bytes. This is the segment. The network layer adds an IP header. It is also 20 bytes. So now we have 140 bytes. This is the packet. The data link layer adds an Ethernet header. It is 14 bytes. It also adds a trailer. It is 4 bytes. So we add 18 bytes. Now we have 158 bytes. This is the frame. So the data started at 100 bytes. It ended at 158 bytes. The extra bytes are the headers. We call this overhead. It is the cost of using layers, but it is a good deal. In return, we get simple layers, and we can send data across many networks. Quick summary. Let's review the key points. Encapsulation means wrapping. On the sender, each layer adds a header. The data link layer also adds a trailer. De-encapsulation means unwrapping. On the receiver, each layer reads and removes its own header. The name of the data changes at each layer. Data, then segment, then packet, then frame, then bits. Remember, do sergeants pay for beer? And one big idea. A layer does not read its payload. It only handles its own header. This keeps the layers simple and separate. Practice questions. Now let's practice. I will ask 3 questions. You can pause and think. Question 1. Put the data unit names in order. Go from the application layer down to the physical layer, and say which layer goes with each name. Question 2. The network layer does not read the TCP segment inside its packet. Why not? Question 3. An app sends 200 bytes of data. The TCP header is 20 bytes. The IP header is 20 bytes. The Ethernet header is 14 bytes. The trailer is 4 bytes. What is the size of the final frame? Now, here are the answers. For question 1, the order is data at the application layer, segment at the transport layer, packet at the network layer, frame at the data link layer, bits at the physical layer. For question 2, to the network layer, the segment is just payload. It is just data to carry. The network layer only uses its IP header. It uses the IP address to find the path. Reading the segment is the job of the transport layer on the other computer. This is the rule of separate layers. For question 3, let's add 200 plus 20 for TCP plus 20 for IP plus 14 for Ethernet plus 4 for the trailer. That is 258 bytes. So the final frame is 258 bytes. Goodbye. That is all for today. Now you know encapsulation. You know it means wrapping. You know de-encapsulation means unwrapping. And you know the 5 names of the data. Great job. Thank you for listening. Practice the funny sentence every day. Do sergeants pay for beer? See you next time. Bye-bye.